Bismillahirrahmanirrahim. In today's video, I am going to discuss the last topic related with the chapter number 9, differential equation relevant with FSC Part 2 mathematics, related with the topic orthogonal trajectories of different type of families of curves. So let's move toward FSC Part 2 mathematics. So chapter number 9, differential equation, exercise number 9.2, lecture number 14. This is the last question of chapter number 9, exercise number 9.2. Inshallah, in the next video, I will solve different type of MCQs based on this chapter number 9, differential equation. So let's move toward question number 13. It tells that determine the equations of the orthogonal trajectories of the following families of curves. So there are total 11 parts. Part number A is y is equal to cx cube. So move to solution. That helps us determine the equation of the orthogonal trajectories of the following families of a curve. So the curve is y is equal to cx cube. Taking the derivative both sides with respect to x, so its derivative dy with respect to x will become dy by dx. C is a constant. Derivative of x cube, d by dx of x cube. So dy by dx, or let's suppose I consider this at a point G, is equal to c time of x cube. Derivative is 3x square. So derivative at a point G is 3cx square. So remember, in orthogonal trajectories, derivative at another point, let's suppose I consider another point F, this is always equal to the minus 1 divided by derivative at another point, which is actually G in this case. This is the definition of the differential orthogonal trajectories. So I finding this, so dy by dx will be minus 1 divided by dy by dx at point G is 3cx square. 3cx square. Now over here I will use separable differential equation. So over here shift dx on this side, it become dy is equal to minus dx divided by 3cx square. Taking indefinite integral on the both side, so integral of dy is actually y, which is equal to minus 1 over 3, c is a constant. So inside we left with dx over x square gives us x power minus 2 dx. So value of y will be minus 1 over 3c into x power negative 2 integration will be x power negative 1 over negative 1 plus constant of integration. So by simplification it become y is equal to minus minus gives us plus, so it become 1 over 3c, s power negative 1 will move to the denominator, it become 3cx. So 1 over 3cx and plus constant of integration. This is actually the required equation of the orthogonal trajectories. Now let's understand the next part of part number B, xy is equal to c. Move to solution. Taking derivative of both sides with respect to x, so it becomes g by dx of xy, and take the derivative of right hand side with respect to dx also. So over here two variable is used, so it means we will use the product rule of differentiation. So the first function x, derivative of second will be dy by dx, plus second function y, derivative of the first function which is x. Derivative of a constant on the right hand side is 0. So it becomes x dy by dx plus d by dx of variable x is 1. So it becomes just y is equal to 0. So from over here we get dy by dx is equal to minus y divided by x. So now for the orthogonal trajectory we will find dy by dx at another point. Let's suppose I consider a point f, which is equal to minus 1 over original derivative dy by dx. So dy by dx will be minus 1 over original derivative is minus y by x. So dy by dx will be, x will move to the numerator, minus minus will cancel with each other, it becomes x by y. Now using separable differential equation, shift y on this side, it become y dy, and shift dx on the right hand side, it become x dx. Taking indefinite integral on the both side, so y dy integration is y square by 2, which is equal to integration of x is actually x square by 2 and plus constant of integration. multiply 2 to the both sides, it becomes y square, which is equal to x square, and it becomes 2c. Now c is a constant and 2 is also constant. So constant multiply constant will give us still a constant. So it means the required answer can be written in this form: y square is equal to x square plus still a constant c. So this is actually the required equation of the orthogonal trajectories. Now let's understand the next part of part number c. Y is equal to cx into e power x. So find the equation of this orthogonal trajectory of this curve. So from over here, the value of c is y divided by x into e power x. So after this, taking the given curve, y is equal to cx into e power x. Taking the derivative of both sides with respect to x. So dy by dx on this side, c is a constant, taking the derivative of x into e power x. So dy by dx will be equal to c. Over here using product rule, so x derivative of the second function is e power x plus second function e power x, derivative of the first is 1. So the required dy by dx will be, c is actually y over x e power x, put over here y over x e power x. From over here take e power x common, we left with x and over here plus 1. E power x cancelled with e power x. So the required derivative is dy by dx, which is equal to y into x plus 1 divided by x. Now finding the equation of orthogonal trajectory by using the formula dy by dx at another point, let's suppose f is equal to minus 1 over original derivative, which is y x plus 1 divided by x. So dy by dx will be equal to, shift x to the numerator, will become minus x divided by y into x plus 1. Now using separable differential equation, shift y on this side, it become y dy, and shift dx on the right hand side, it become negative x dx over x plus 1. Taking indefinite integral on the both sides, so y dy integration will be y square over 2 is equal to, over here I cannot integrate it directly because this is improper fraction. So over here I do some substitution, so I add with x 1 and subtract also 1. In the denominator we have x plus 1 and whole dx and indefinite integral. So it become y square by 2 is equal to, over here I can write it in this form: minus into x plus 1 over x plus 1 minus x plus 1 over x plus 1, taking integration, and minus into minus plus 1 over x plus 1 plus 1 over x plus 1 and take integration. So minus into x plus 1 over x plus 1 and minus into minus plus 1 over x plus 1. So it become y square by 2 is equal to x plus 1 cancelled. So it become minus integral dx and integral 1 over x plus 1 dx. So it become y square by 2 is equal to integral of dx is minus x and its integration is ln of x plus 1 and plus constant of integration. This is the required equation of the orthogonal trajectory. Now let's understand the next part of part number D. Y square is equal to x square and plus c. Find the equation of orthogonal trajectory. Move to solution. Taking the derivative of y square with respect to x. Also take the derivative of right hand side with respect to x square. So on the left hand side, derivative of y square is 2y, and also y is an inner function, so it becomes dy over dx, which is equal to derivative of x square with respect to x is 2x, and its derivative is 0 because this is a constant. 2 cancelled with 2, so the required derivative is dy by dx is x over y. Now using the formula another, dy by dx at another point, let's suppose at f is equal to minus 1 over the original derivative, which is x over y. So furthermore simplify, it become dy by dx will be equal to, shift y to the numerator, become minus y divided by x. Now using separable differential equation, shift y on this side, it become dy over y, and shift dx on the right hand side, it become minus dx over x. Taking indefinite integral to the both side, so 1 over y integration is ln of y and 1 over x integration is ln x, so it becomes minus ln x, and with constant I can take ln, so it becomes ln of y. Over here it is minus and it is plus, so the formula will be used ln of this c divided by this x. So this is formula ln of a minus ln of b, which is equal to ln of a by b. So ln of a and by b, so ln of c by x. So taking exponential to the both sides, so e cancels with ln, so it becomes y is equal to c by x. So the required and desired answer in curve is c is equal to yx. So this is the required equation of the orthogonal trajectory. Now move to the next part, of part number E. It tells that y is equal to c into sine of 2x. Find the equation of this curve. So move to solution. First of all, it is y is equal to c sine 2x. So from over here, c is equal to y divided by sine 2x. So furthermore, taking the given curve, which is y is equal to c sine 2x. So taking the derivative of both sides with respect to x, so dy by dx will be, c is a constant, and taking the derivative of sine 2x. So dy by dx will be c into sine 2x, derivative is actually cos of 2x, and derivative of 2x, this is inner function, this will derivative is 2, so the whole derivative will be 2 cos 2x. So furthermore, dy by dx will be, c is actually y over sine 2x, so it becomes y over sine 2x and 2 cos of 2x. So dy by dx will be 2y, and cos over sine gives us cotangent 2x. 2y cotangent 2x, this is the dy by dx. Now finding derivative at another point, let's suppose f, which is equal to minus 1 over original derivative, which is 2y cotangent 2x. So dy by dx will be minus 1 over 2y cotangent 2x. Now shift y on this side and also 2, so it becomes 2y dy, 2y dy, and shift dx on the right hand side, it becomes minus dx over cotangent 2x, taking indefinite integral on the both sides. 2 is a constant, so write it outside. Integration of y is y square divided by 2 is equal to, it becomes minus integral of 1 over cotangent is actually tangent 2x and dx. Further simplify, 2 cancels with 2, we left with y square, which is equal to minus time of integration of tangent is ln secant x. So over here 2x, it becomes ln of integration of tangent is ln of secant 2x, because the function is 2x. So ln of secant 2x, also take the derivative of this 2x in the denominator, it becomes 2. So minus ln of secant 2x over 2 and plus constant of integration. This is the required equation of the orthogonal trajectory. Now let's understand our part number f. E power x into cos of y is equal to c. Find the orthogonal trajectory equation of orthogonal trajectory. So move to solution. Taking derivative of both sides, so d by dx of e power x into cos of y, which is equal to c, d by dx of c. So over here we have two functions. So using product rule, so first function, derivative of the second function cos of y plus second function cos of y, and derivative of the first function e power x. Derivative of constancy is 0. So it becomes e power x, so derivative of cos of y is minus sine y. Y is an inner function, so its derivative will be dy by dx, so plus of cos of y, and derivative of e power x is e power x, which is equal to 0. Further it becomes minus e power x, so sine y. dy by dx is actually the first time derivative, which can be written as y ratio, which is equal to, shift this on the right hand side, it becomes negative cos of y into e power x. So e power x cancelled with e power x, negative cancelled with negative, and cos of y over sine of y. So y ratio, which is actually dy by dx, is equal to cos by sine, gives us cotangent y. So now finding another derivative. so dy by dx is equal to minus 1 over original derivative, which is cotangent y. So dy by dx will be, it will give us minus 1 over cotangent y is tangent y. Shift tangent y on this side, it becomes gy upon tangent y. Shift dx on the right hand side, it becomes negative dx. Take integral. So 1 over tangent y is actually cotangent y, and dy is equal to integral of negative dx. So cotangent y integration is ln of sine y is equal to minus integral of dx is x and plus c. Now taking exponential on the both side, so e cancel out with ln, we left with sine y, which is equal to e power negative x into e power c. We can write it in the split form. So over here e is a constant, and constant power constant gives us still a constant. So sine y will gives us c. So c e power negative x. So the value of y will be sine inverse c e power negative x. This is the required equation. Now let's solve part number G. Y is equal to square root of x plus c. Find the equation of this orthogonal trajectory and this curve. So move to solution. Our curve is y is equal to square root of x plus c. Taking square on the both sides, so it become y square and it become x plus c. Taking the derivative of both sides with respect to y. So y square derivative with respect to y is 2y, and y derivative is gy by dx. Is equal to derivative of x with respect to x is 1, and derivative of c is 0 because it is a constant. So from over here, gy by dx is equal to 1 over 2y. Now using another derivative, gy by gx at another point f is equal to minus 1 over gy by dx, which is 1 over 2y. So dy by dx will be, shift 2y to the numerator, it become minus 2y, divided by 1 gives us minus 2y. Shift y to this side, it become gy by y, and shift dx on the right hand side, it become minus 2 dx, taking indefinite integral on the both side. So it become 1 over y integration is ln y, which is equal to integration, minus 2 is a constant, integration of dx is x, and plus constant of integration. Taking exponential to the both side, so exponential cancel out with ln, we left with y, which is equal to e power minus 2x into e power c. E is a constant, power is also constant, so constant to the power constant gives us still a constant. Let's suppose c, so c e power minus 2x. So this is actually the required equation. Now let's understand our part number h. Y is equal to x square plus c. Find the equation of this curve. So move to solution. Taking the given curve, y is equal to x square plus c. Take the derivative of both sides with respect to x. So dy by dx will be x square derivative with respect to x is 2x, and c is a constant, its derivative is 0. So dy by dx is 2x. Now dy by dx at another point, let's suppose f is equal to minus 1 over gy by dx at original point, let's suppose g. So it will be minus 1 over dy by dx at original point g is, let's suppose 2x, and this is dy by dx. So furthermore, shift dx on the right hand side, it become gy is equal to minus 1 over 2 and gx over x, minus 1 over 2 gx over x, taking indefinite integral on the both side. So integral of dy is y, minus 1 over 2 is a constant, integration of 1 over x is ln x, and plus constant of integration. This is the required equation. Now let's understand our part number I. E power x into sine of y is equal to c. Move to solution. Taking the derivative of both sides with respect to x, so d by dx of e power x into sine of y is equal to derivative of c with respect to x. So on the left hand side, two variable is used, two function is used. It means we will use the product rule. So the first function, derivative of second function with respect to x will be cos of y gy by gxo because y is an inner function, plus second function sine y. Derivative of the first function e power x is e power xo is equal to derivative of a constant c is 0. Further it become e power xo cos of y gy by dxo. Shift this on the right hand side, it become negative sine of y in e power xo. E power x cancel with e power xo. So dy by dx will be minus sine y over cos y gives us minus tangent y. So this is the dy by dx. So now finding dy by dx at another point, which is equal to minus 1 over original, which is minus tangent y. So it become gy by dx will be minus cancelled with minus, we left with 1 over tangent y. Shift tangent y on this side, it become tangent y dy, and shift dx on the right hand side, it become gx, taking independent integral on the both sides. Tangent y integration is ln of secant y. Integration of dx is x and plus c, taking exponential to the both sides. So on this side we left with secant y is equal to e power x into e power c. E is a constant, c is a constant, x will give us still a constant c. So secant y is equal to e power x into c. This is the required equation. Now let's understand part number J. Cos of x into cos of hyperbolic y is equal to c. Move to solution. Taking derivative with respect to x of both sides, cos of x, cos of hyperbolic y is equal to d by dx of the right hand side c. So on the left hand side we will use product rule. So first function derivative of second function plus second function cos hyperbolic y derivative of the first function cos x is equal to derivative of constant c is 0. So it become cos xo. Derivative of cos hyperbolic y is sin hyperbolic y plus cos hyperbolic y. Cos x derivative is minus sin x is equal to 0. So it become cos x sin hyperbolic y. Over here derivative of cos hyperbolic is sin hyperbolic y, but y is an inner function, so also we will take derivative, so it becomes dy by dx, gy by dx. Shift this on the right hand side, it become, over here it is negative, so by shifting to the right hand side it become positive, sin x and cos hyperbolic y. Divide with cos x both sides and sin hyperbolic y. Cos x cancel with cos x, sin hyperbolic cancel with sin hyperbolic. So dy by dx will be sin by cos gives us tangent x. Cos by sin gives us cotangent hyperbolic y. This is dy by dx. Now taking another derivative, dy by dx is equal to minus 1 over original derivative which is tangent x cotangent h y. So it become shift dx on this side and cotangent on this side, so it become cotangent hyperbolic y into dy is equal to minus dx over tangent x minus dx over tangent x cotangent y into dy, and take integral. Cotangent hyperbolic y integration will be, it can be written as cos of hyperbolic y over sin hyperbolic y into dy. Integral is equal to minus 1 over tangent x, so it become cotangent x dx. So over here if we take sin hyperbolic y, its derivative is present in the numerator which is cos hyperbolic y. It means its integration is ln of sin hyperbolic y, which is equal to minus time of cotangent x. So integration will be, we can write it in this form, cos x over sin x into dx. So sin x derivative is actually cos x, which is present. It means its integration will be minus sin x integration derivative is cos x. Integration will be ln of sin x minus ln sin x and plus ln of c. So it become ln of sin hyperbolic y which is equal to ln of c divided by sine x. This is the formula, c over sine x. Ln cancelled with ln by taking exponential on the both sides. So sine hyperbolic y into sine x will be equal to c. So c is sine x into sine hyperbolic y. This is the required equation.